Okay, I guess the traffic on YouTube is starting to get so intense that you actually have to listen to what they're saying to do. Um, I had to revert all of my because I use this QuickTime player on my Mac down here for and I've been getting away without having to revert them to MP4 files, but now I have to. But it was starting to get to be like it was taking me 30 minutes or 40 minutes to download um, and you all are going, why do we care about this? I don't know. I'm just throwing this out. But anyway, I finally figured out how to download it to an MP4 format. So now things are uploading very nicely, and things are moving along. Now this problem is just long and tedious. Okay, it's long and tedious, but it'll reinforce a lot of ideas. So basically, we've got three objects, and we're going to assume that they are just masses that have no that are just like dots. All right, and the mass of each and each rotates about the z-axis. So the z-axis is what's coming out of the page. Let me just show you real quickly how to do this problem. All right, they're showing you the relationships between. So we've got three objects. Now the z-axis is the axis that's coming out of the page straight at you. Okay, that's the z-axis. All right. So my pen represents the z-axis. So I've got an object here, and it's pinned down here at a certain point in the xy plane, and it's spinning. Okay, and we're going to find its tangential speed, so I don't really care about its tangential direction. All right, so I'm not going to say the velocity, the tangential velocity. I'm going to find the tangential speed. So it's rotating about this right here, and we're going to pretend it's just a point. All right, and if you're given omega, given omega is given, let's say it's 2.4 radians per second, like it was, like I just saw, and you're given the radius r. Let's say r1. In fact, I can flip back real quick and find out what r1 is. For all of them are spinning at 2.40 radians per second in my problem, and m1 is 7.5 and r1 is 6 meters. Okay, so that's pretty hefty meters there. All right, good. All right, so and you're given the radius. So r1, this is omega for all of them is 2. And r1 is 6.0 meters. And what was the mass? 7.5 kilograms. All right. And the mass of one is equal to 7.5 kilograms. Okay, obviously they want the answer in 3 sig figs at least because they've got 3 sig figs listed there. So let's take a look. So we got R1. So how do we find that radial speed? Well, I know this. I know that omega times r times omega equals either the axial speed if it's rolling along or just the tangential speed if it's stuck and spinning. These are stuck in one place and spinning. All right. So, oh my gosh, that's all we got to do is multiply r times omega to find the tangential speeds? Yeah. So that's how you find the tangential speed. Then I want you to calculate the kinetic energy. So this thing is moving around now remember, with energy is a scalar. Energy is a scalar, so it's just 1/2 mvt squared. Well, that's not hard. But wait, there's more. This problem is kind of like Ginsu knives. Okay, but wait, there's more. Now they want you to calculate the total kinetic, the kinetic energy. What else did they want us to do? Okay, so we'll find A. The tangential. So A, B, and C are simple. Okay, you just take R times omega, R times omega, R times omega. All right, and I've got to work on that tolerance too of plus or minus 2%. That's kind of intense. And then they want the total kinetic energy of the system, total kinetic energy of the system, and then they want the total rotational kinetic energy of the system. All right, so because it's not rolling, so you're just going to add up. Just going to add those up like that. This is your kinetic energy based on the tangential. Now, what about the kinetic energy of omega? That's 1/2 I omega 1 squared plus 1/2 I omega 2 squared plus 1/2 I omega 3 squared. Now they didn't tell you what I was. They just made the assumption that this is just three objects, going about this R, and so they're saying that R1 is equal to the mass of 1 times R1 squared. I2 is equal to the mass of 2 times R2 squared, and I3 is equal to the mass of 3 times R3 squared. So yeah, it's a kind of a long accounting type problem, but when you go through the practice of doing this, now write these down. Don't just sit there with your calculator and go digit number. No, actually practice so that because this transfers it to your brain. All right. Now look what happens when I take just VT squared. Okay. Well, VT squared is equal to R squared omega squared. Aha! Aha! So therefore, omega squared is equal to VT squared over R squared. So look what I wind up with. When I plug this term into here, I get this term. When I plug in 1/2 times M1 R1 squared times VT squared, VT1 squared over R squared, look what happens. The R's cancel. Piece of cake. Gotta love it.